Welcome, everyone, to the second part of Introduction to Charming. I'm going to start giving a very fast-forward recap of what we went through yesterday, just to refresh everyone's minds. Those of you who were not here yesterday, such as Jose and whoever else, you might here and there feel a bit lost, but don't worry. I hope everything will be clear in time. The picture that I tried to sketch yesterday, when it comes to new concepts, it was more than an introduction to Charming. It turned out to be more of an introduction to Juju, which is fine. The picture that I described yesterday is this. We have the Juju CLI that we use to type commands, send information over to Juju controller. The Juju controller, in turn, updates its internal model, its internal state, and fires off events to any number of charms, updating them of the changes that have happened in the model that they might be interested in reacting to. The charms, in turn, are, well, they are like, as an artifact, a charm is a zip file containing a virtual environment for Python to provide all sorts of dependencies, including ops, the operator framework, which is a Python library that exposes a Pythonic API that the charm code at runtime can use to interact with Juju. With Juju as in the Juju controller, right? The charm talks to the Juju controller. Or rather, the charm talks to the Juju unit agent, which lives in the charm, and the unit agent talks back to the controller and back and forth. The controller has this database where it stores the model information, such as what applications are there, what units are there, what relations there are, what data is in those relations. And the charm, through the operator framework, can read and write some of the pieces, some of these pieces of data. And we have seen that, yeah, so like I gave a bit of an overview of the Juju CLI, of the things you can do, such as deploy charms, relate, remove relations. I went a little bit through JHack and a few of the commands that I use the most in order to track what's going on in a Juju model. And while I was explaining all of this theory stuff, I wrote a charm, a very simple charm that does very little. It's a demo charm, so yeah, not meant for production. It doesn't have a lot of logic in there. It's meant to deploy nginx on a machine model, so it's a machine charm. If you didn't have this repository at hand yet, you can clone it, you can check it out, and at the moment we're working on the branch called Part 2 integration. So this branch contains the working code of the Introduction to Charming charm that I wrote yesterday, or yeah, a copy of it. And let's go for 1 second again over the logic that this charm contains. Charms, well, you implement them as by subclassing this ops charm-based object, which is provided by the operator framework. I'm going to refer to ops and operator framework interchangeably. They're one and the same. And yeah, the entry point of the charm is the constructor. And in the constructor, the first, or let's say the most important thing that a charm needs to do in the constructor is register event observers, or event handlers, we usually call them. And you do that by calling self.framework.observe. Essentially, that registers a conditional callback. What this line says is, if I am processing an install event, then execute this function and pass to it an event object as first argument. So this is the handler for the install event. We have also seen the charm events graph, which is this huge graph containing like all of the events that a charm goes through on the life cycle, on its life cycles. We've seen that there are 3 phases: setup, operation, and teardown. And in this case, we are looking at the install event. So that is during the setup phase, when the charm is being provisioned by Juju, and Juju is notifying the charm, you're alive, you're ready, your machine is ready to go, and install whatever software you need to install. In our case, since we're installing nginx, we are in fact installing nginx. We temporarily set maintenance status to notify the user, as in the cloud operator, the charm is busy installing nginx. And we open a couple of scripts, a couple of lines of bash commands that we use to install nginx and configure a firewall in order to allow nginx HTTP traffic. Now let's pack this. And then we're going to deploy it so we can see in real life. I'm going to start with a clean model, demo 1, so that we get rid of all of the logs from the previous runs. And as soon as charmcraft is done, putting together the charm artifact, which again is just a zip file. We opened it up yesterday and took a pic of what's inside. And we're going to call this nginx. This charm artifact, so this zip file, is being uploaded to the controller, which is creating and provisioning a virtual machine in this case, because I'm on a local LXD model, nothing fancy. But if it's backed by mass, then we would have a mass provisioner behind. This is the Juju status, and we can see that the machine is in a pending state, which means that the VM is starting. It's probably installing Ubuntu 22.04, and that is our status. In the meantime, we can start jhack tail, which has not received any events yet, because we are even before the start phase, the startup phase of the charm, because the charm is not even on the machine yet. So that might take a couple of seconds. While this happens, I'm also going to show you the tester charm. So this is like I'm going to talk a bit more about testing later, but when you write a charm, there are 2 big categories of tests that, at least in our team, we usually write, and there are unit tests and integration tests. And like the line that we draw is unit tests, there is no Juju running. Integration tests, there is. So when you have an integration test, you have a charm, you pack it, you deploy it to a temporary Juju model. You pack another charm, which could be a tester charm, or maybe you deploy a real third-party charm that you want to test your charms with. But that is sometimes trickier, because then you depend suddenly on the third-party charm. So often we write our own tester charms, which are very, very minimal charms, and all they do is present a facade for the integrations that the charm that you want to test supports can talk to. So in our case, we have also discussed. We have also written yesterday a very simple library for called ingress, demo ingress actually, and the design of this library is in fact also very bare bone. The idea is that the requirer charm sends to nginx, so to our tester charm, a port and a host that it wants to be exposed, and the nginx, the demo charm, replies with an ingress URL. If this were a real nginx charm, you would also use this host and port to generate forwarder rules. But in our case, we don't really care about that because we're just demoing. So in lib charms intro to charming MC v0, you can find this demo ingress library, which implements, which exposes two classes, an ingress provider and an ingress requirer. Provider requirer is this Juju terminology, but it is standard practice, I would say, to offer something provider and something requirer in a charm lib, so that the charm, like in this case, the demo charm, can instantiate the ingress provider object on itself to kind of encapsulate the logic related to providing ingress. That is what this object represents. And the tester charm, in turn, will implement, so will instantiate, will use the ingress requirer object to encapsulate the other side of the relation, so the part of the relation that is requiring ingress. How to design these objects and how to give them an intuitive API, and yeah, like there is a lot more to go through on how to design these properly. There's a lot of good examples out there. Every team has probably their own best practices when it comes to how to design these objects. I don't think we have yet a lot of standardized processes for that, but yeah, I'm not going to be able to go into that with too much detail. Yes. Let's go back for a second to our Juju. We see that the unit is provisioned. So we have an nginx unit with status active idle. And in JHack tail, we can see what events this charm has seen so far. It has seen an install, leader elected, config changed, and start. And if you remember this graph, this is this flow: install, leader elected, config changed, start. Now the charm is in this operation phase. And operation phase is basically the Wild West. I said yesterday, is where anything can happen, because depending on the cloud admin, what he or she does, the charm could receive any of these events, right? So from the perspective of the charm, you should not make any assumptions about what event you're gonna see next. For example, the charm has just seen an update status event, which is quite a special event, I would say, because it is fired periodically and automatically by Juju on the charm by default every 5 minutes. But if you want to test it, more when you're doing development, you can either do Juju config update status something. Wait, model config. Yeah, update status hook interval equals, for example, 5 seconds. and that is going to cause the update status event to fire every 5 seconds. Or, of course, there is a JHack shortcut for it, which is JHack fast forward, which essentially does this and keeps doing it in the background until you Control-C. So you can see now the nginx charm is starting to see a lot more update status events until we stop it. Yesterday, I was when we closed, I was implementing this tester charm for the relation interface, and so let's go and pack that one. Integration tester. So the tester charm, I don't remember if I created it live or if I just magicked it into existence, but it's essentially created the same way as you would create a regular charm, only the source code is extremely simple. It's 40 lines of code in total. It has a single catch-all event handler, which has a very simple control loop. What it does is it checks if the ingress require object that we have defined here, if it has any relations. So if there are any relations that are active on this endpoint, then it is going to set one of three statuses, either waiting status if we have requested ingress. So if we have forwarded host and port, but we have not received a URL back yet, it will set active if we have forwarded host and port and we have received a URL back, or it will set blocked status if it cannot find any ingress relations, right? So when we pack this charm and deploy it, which will take a second, as soon as we deploy this charm, question for the audience, and you don't need to reply, but at least think about it. When we deploy this charm, what status will it have? You have a couple of seconds to think of the answer. And say it if you dare. No one? The waiting is the status. So it's going to be blocked because when you first deploy the charm, there's going to be no relation. So you're going to have two charms living next to one another, but no integration yet. Before you create, before the charm sees a relation, yeah, waiting for machine, of course. But that is because but that is not the charm status. Technically, that is, I guess, unit status. Not sure. By the way, only once you do Juju relate nginx tester, the relation will appear, and Juju will be aware of the existence of it. So you can see that the tester is indeed in blocked idle. Idle because there is nothing happening at the moment because the charm is not executing. And the message is awaiting relation with demo ingress provider charm. So now let's relate them. And by the way, we can take a look also at the events that this charm has seen. You will notice that there is also this collect unit status and collect app status. They are not Juju events. They are events fired by the operator framework on the charm itself to allow it to set status. It's a bit of a new addition to the operator framework, and I'm not going to go into too much detail here on how to use it. But what you need to know is don't be surprised that you don't see them in this graph, because they are not emitted by Juju. They're emitted by the operator framework. Long story. All right, so let's relate the two of them. And then we're going to see a bunch more events appear in the tail. Indeed, both charms receive first a relation joined and then a relation changed. I mentioned yesterday, and I stressed, I think, quite a bit, that there are few, like very little dependencies and few dependencies between events in the operation phase, but relation joined and relation changed is one of them, right? So you see an arrow here. After you've seen a relation joined, you will always see a relation changed. That is actually pretty much the only one in the operation phase. But so yeah, this matches the expectation. The semantics of the different events, you can find that detailed in the documentation, but what the relation join means is that the relation has been it's like that a unit has joined the relation. So the data bag for that unit has become available and can be written to and read from. While ingress relation changed, that one happens when when the remote side has written some data to the data bag. Let's take a look at what is in those data bags. Show relation, nginx, test. All right. This table shows you the picture that the charms, both of them, have access to. The interface of the relation is demo ingress. We have touched yesterday briefly upon the difference between the endpoint, which is the private name that the charm calls the kind of the slot where this relation can connect, and the interface, which is the name of the protocol, the information exchange protocol that these two charms have agreed to be using over those endpoints. And we have implemented it this way, right? So we have implemented the ingress requirer to publish host and port to the application data bag of this relation, and the nginx charm to publish the URL to their own application data bag. Someone asks in the chat, is it fine if we observe only changed, or else what should we add in the observer of joined? Yeah, good question. So it depends on, like, first of all, not all charms, not all relations put data in the data bags. Sometimes the information carried by the fact that there is a relation in and of itself is enough for the charm to do whatever it needs to do. That is kind of an edge case, but it is conceivable that it's enough to listen to joined to know that you have another unit, and that you have a unit on the other end, and you need to do something about it. And also something you need to consider is that when I add a new unit, when I scale up the tester charm, for example, a new unit is going to appear, but the application data bag is not gonna change because that is owned by the leader of this charm. So it's not going to be modified. That said, I do think that the nginx charm will still receive a relation changed event. So, well, in short, it's perfectly fine if you only observe changed. You don't need to observe joined. You don't need to observe relation created. It's, yeah, like if your charm needs to do something on joined or created, you will know, and then you're free to observe them in isolation. But I cannot think off the top of my head of a use case or specifically. Yeah, like someone suggests in the chat to maybe install an extra snap package. Yeah, I think that you would be expected to install all the dependencies you need in install or start. So like at the start, at the setup phase, not while you're receiving an integration. We have also, yeah, maybe it happened a bit fast, so it was hard to see, but the tester charm went through the statuses that we had expected. So it started off as blocked. Then it went to waiting for a split second because the relation is created, but the nginx charm did not publish yet the URL in response to the testers publishing. So it's a back and forth, right? Tester publishes some data, nginx receives a relation changed event, publishes some data in return, tester receives a relation changed event, and does something again. You can see something like a log of that by doing Juju show status history. Tester 0, yes. So this is the history of the statuses that this charm went through. You can see that indeed it started at allocating, waiting for a machine, installing agent initializing, and this is the first workload status that the charm has set. Then we go into, yeah, we execute the relation created, relation joined. Then we go into waiting, which is when the charm has forwarded host and port, but it has not received the URL back. And it goes to active when finally the nginx replies with this URL. And that is how we got to where we are.
Just a comment, Pietro, about the previous topic about the relation and the idea we only have to listen to relation change, or we should also listen to relation join.
Mm-hmm.
I was checking in our code in some of our chunks, and there are some situations in which we listen relation join and also relation change. For instance, in the provider side of a relation, when the provider side sees a relation join, may want to send a specific data to the relation data at this time. For instance, I was checking the Loki charm. The Loki is providing an endpoint for receiving logs, and also is sending the require a URL of a binary that the require should install in order to start sending logs to Loki, right? So in relation join event, we are sending this URL so the require can download the binary. Then in the relation change, we may send another data to the required side of the relation. For instance, we send our endpoint and our port. So this is maybe a pretty good example in which we can see that some type of data, it is necessary to be sent when you actually see that another unit is joining the relation, and certain type of data, it's useful to be sent when the relation is established and you are sure that everything is in place.
Yeah, thank you. Keep an eye on what's happening in here and what's happening up there. A new data bag has appeared in the relation data. So the application, there is only one application data bag per application, as the name suggests, and it is owned by the leader unit. So that is the one with the little star in the status, which in our case is tester 0. Then each unit has a unit data bag, and the moment that we create a new unit, JHack already knows that there's a data bag coming, but yeah, like Juju has not quite provisioned the unit yet, so there is no events yet. But what I expect to see is that soon there's going to be a new tester 1 column up there in tail, and you're going to see the whole setup sequence, install, leader settings changed, config changed and start, and then there's going to be a relation created, joined, two joined or one joined, and then a changed. There we go, changed and joined. Yes, changed and joined. Yeah, the created has happened, I hope, before, because that should, yes. Start config changed, is created, install, joined and changed. Yes. I say we do a little bit of hackery just to demonstrate, well, a little bit of how I do debugging and development of code interacting with relations, and also just demonstrating what debugging facilities are there built into Juju or JHack that we can use. There are at least two useful commands in Juju that I know for debugging. They are debug hooks and debug code. Juju debug hooks and Juju debug code. They are different, but they kind of operate in similar ways. Debug hooks it sets up a breakpoint in a unit and waits for the next event to occur. But the breakpoint is not inside the Python environment yet. So you are, if you remember the picture, the model that I already reiterated on previously, the Juju controller fires an event to a unit. In this case, you see sidecar, pebble. Like this is a graph that was meant for Kubernetes charm, so just ignore the pebble and sidecar things. The controller invokes, calls the Juju agent, unit agent, which calls the dispatch script, which executes the charm with a bunch of environment variables. And the point in time at which we are injecting the breakpoint is here, this line, right? So we are in the point in time before dispatch is being called. So let's do tester 0. We see as well, I guess it's a ZSH session opening up there. I actually want the tail to be open. And let's do fast forward so that we get an update status event. And we should see here, there we go. So this is the breakpoint being hit, okay? The instructions up there are not very self-explanatory, but this is Juju debug hooks tmux session. You need to execute hooks and actions manually if you want to run them for trapped events. When you're finished, you can run exit to close the current window and allow Juju to continue processing new events without exiting a current debug session. Okay, so where are we? We are inside the charm. We are inside the, well, inside the charm. We are inside the tester 0 unit, so on machine 1. We are in varlib Juju agents, unit tester 0 charm. So this is where the charm package has, the zip file has been unpacked. You can also actually still see it here. So you see that there's the charmcraft YAML, there's the dispatch file, there's a mysterious hooks directory, which I wouldn't worry about, it's legacy. There is SRC, where this is our charm code, right? So what happens if we do dispatch? If we call dispatch, the charm gets executed. So, and we can do this more and more and more, right? So what we're seeing here, and by the way, you notice that the tester, the JHack tail is showing new events appear up there. And this is because the charm code is executing, the operator framework is emitting logs that we can also see in the debug log. Sure, that's going to be obvious, but yes, there we go. And these logs are being picked up by JHack tail. So the event is running, the charm logic is executing, and one of my favorite ways of interactively and quickly debugging a charm where something weird is going on is to start up test separation tester, is to open up a JHack sync session, so I get to edit the file locally, which is just a little bit easier for me than installing Vim or just editing the file from here. I could also, of course, Vim the charm file from there. But I can edit this file here and do all sorts of things, like logger error, okay, there, or something. Save the file, it gets synced to, by the way, tester 0 and 1. At the moment, we're looking at 0. We call dispatch, and we get the error log. We get the error log, right? So you can see how this is useful for debugging. You can also use this technique for exploring the charm API, right? So if you want to know what relations does my charm think he has, or what data does the charm see in those relations, then you can do that in here. Self-model relations over then ingress, I presume, or was it ingress demo? Demo ingress. So what happens if I do this? It's going to print a dictionary. So this shows you how the charm accesses the Juju model data. In particular, if you like this .data attribute refers to the operator framework's wrapper for the data bag, so this data structure. And I think I have introduced the bug, but where was that thing? Oh, here. And it gets presented to the charm back as a dictionary, string-to-string mapping, host, this cluster, local SBC, whatever, which is here, and port 4242, which is there. And we can also, well, why not? Let's touch that data. So let's do this. Unit to bar. So now we are not reading data. We are setting data. What happens if I execute this charm now? You can see that the data has appeared in my unit data bag. If you are curious where this data is coming from, because this is JHack, this is not native Juju interface. This data is coming from putting together the output of a bunch of Juju commands, such as Juju show unit. In this case, nginx 0. This shows a bunch of stuff, including the application data bag, where you can see exactly the same data structure, and foo bar, which is the unit data bag of tester 1, because that is where we are. Hacking around. Someone asks in the chat, who is checking that I am a leader and I am allowed to do it? That is Juju. So right now we are doing, we are working in tester 0, which is the leader. So let's do a debug hook session for tester 1. And let's fast forward so we hit a breakpoint. And then I'm going to try and do the same from a non-leader unit. So by doing this, I am attempting to set a key, to set a value in the application data bag of this relation. And what happens when I call dispatch? Error. The error message says cannot write relation settings. This error is raised by the operator framework, but in fact it comes from Juju. I mentioned last time that the operator framework wraps two things: the environment variables, which, by the way, yes. So you can see here what kind of environment we're talking about. This is the charm, the environment that the charm code is running with. It contains Juju-specific stuff, such as where's my proxy? Do I have a proxy? What's the name of the principal unit if this were a subordinate charm, but it is not? Where is my charm directory? Juju debug, yeah, so there's information about this debugging session that we're in. There's a Juju agent socket address, Juju hook name. This is the name of the event that is executing right now, right? So that is what is telling the charm the event that it should be running. So this is the environment that the operator framework wraps. So when in the operator framework you do self unit name, that is in fact that is in fact returning this value, which is an environment variable, right? So when I do self-unit name, the operator framework is loading that from an environment variable. So that is the environment wrapping that the operator framework does. And the second thing that the operator framework is wrapping is the hook tools. Hook tools, which are tools. Okay, look, they are. So these are all of the hook tools that there are. And when I use the operator framework, so when I do this, let's translate that to hook tools. So let's basically let's unwrap what the operator framework is wrapping for us. That would be relation set. And that is kind of also complicated because we need to get the relation ID, which is fortunately, I think, 0. Yes. Relation set, they also have a help, by the way. So you can, okay, relation set -r -app, because we are attempting to set the application data bag full bar. Okay, so this is the hook tool that we're attempting to call, which is relation set -r0 -- application, because we're attempting to write the application data bag, and foo bar. So what this means is please go and write the application data bag of this relation and put in there foo equals bar. And Juju replies with no can do, cannot write relation settings. Let's remove the --app. And it goes through. Why does it go through? Because if we omit the --app, we are writing the unit data bag. So this means that this works because, well, every unit has write access to their own unit data bag. So unit data bag or something, we can write that. And if we do show relation, we should hopefully see them here. Wait, we are in tester 1 at the moment. But again, it's being kind of slow today. I'm not sure why it takes so long. Oh, wait, I know why it takes so long. Because it only, these changes only take place when the charm, when this process exits. So I guess now, yes, there we go. So we have written the unit data bag, but we cannot write the application data bag. And who checks it is ultimately the controller. It just, by using the hook tools, the charm asks to the controller, please do this. Controller replies with an error, and you have to deal with it. Now, in ops, that means exceptions, right? So if I want, what you often do then in charms is to use a leader guard. There is a hook tool called isLeader. Wait, I cannot. Yeah. Oh, there is an isLeader, which returns false in this case. It would return true if I were in unit tester 0. And in operator framework syntax, that is unit isLeader. So this means if I'm leader, attempt to write the application data bag. If I'm not leader, write it to unit data bag. I hope this answered that question and some. Now, I wanted to show you Juju debug hooks. And the second interesting debugging command that Juju offers to you is Juju debug code. The main difference between the two is that while Juju debug hooks sets a breakpoint here, so before dispatch occurs, Juju debug code sets up a breakpoint here in the event handler, the first line of the event handler. So it's tantamount to setting up a breakpoint in this line, but then on a live unit. And it works in a very similar way. You do debug hooks tester 1. We enter a tmux session, which is waiting for an event to happen. We fast forward, or like I am demonstrating these tools with the update status event. But if instead of fast forwarding and waiting for an update status event to happen, I could remove a relation, add the relation, and then it would be like, and then you would hit the breakpoint not on update status, but on relation created, relation removed, or any other event, right? Only it's sometimes complicated to reproduce a bug with a specific event because maybe you need to remove a relation and add it back before you hit exactly the event you're waiting for. So yeah, like I'm just doing it with update status for demo purposes. But I think why am I showing debug hooks? I did the wrong thing. I meant to do debug code. There we go. This little trick, yeah, like I only ever use it when I suspect that Juju is stuck with the status of some charm, and like okay, maybe something that I should mention about events is that if an event fails, as in it raises an uncaught exception, which means that dispatch will exit non-zero. That means that Juju is going to attempt to rerun that event over and over until it exits 0, which sometimes is not what you want, because sometimes you know it's never going to return 0. So in those cases, you can do Juju resolve name of the unit -- no retry, which essentially tells the Juju, don't worry, set this charm to active idle. There is no bug. You only dreamt it. So in this case, I hope it's going to get us out of trouble. And let's see if we can show. There we go. So we are again into the same tmux session as Juju debug hooks provisioned for us before. Only now we are in a nested PDB session, which yeah, for those of you who don't know it, is an interactive debugger for Python. So it is we are right now in a breakpoint in the charm execution flow. And if you type L, you can see, for example, where the pointer is in the charm execution context. So if I type self, I am the charm. This is we are the charm. If I type self unit, you can see the ops model unit object. And I think personally this is a very good way to familiarize yourself with the API and let's say get yourself used to thinking like a charm. if let's try to get a hold of the relation object. This is our relation. Relation data self app is empty. Relation data self unit contains a bunch of stuff. For example, foo, it contains bar, which is what we have there. Right. So this is just a way to modify data at runtime and just debugging debugging charm code. You can advance the pointer in the instructions, right? So you can execute line by line your handler, and if an error is raised, you can see whatever is wrong with it. There's this document that I shared, that I also shared yesterday, where I go through what pieces of data are synced at which point in time in the execution of a charm. Because as we saw before, when I in the charm code I do relation data self unit foo equals bar or something like when I update relation data, for example, it is not reflected immediately in the data model. The relation changed event does not occur immediately. Everything is only submitted to Juju, to the controller, once the charm exits. And importantly, only if it exits 0. If it exits 1, Juju is in fact going to basically ignore all of the changes that you have submitted to it up until that point in time. The one exception, I think it's the only exception, is status. Okay, so you can see it there. And this is a good way to familiarize yourselves with when exactly those data that data syncing happens. There is also a daunting, but I hope kind of accurate graph that explains the data lifecycle of a charm. So at setup time, the operator framework fetches some data from the model, such as charm config, stored state. We didn't get into that because we don't have time, but some data is lazily fetched on demand, such as relation data. Some data is a point-in-time check with some caveats. For example, container connectivity in Kubernetes applications, unit and application status, and leadership. So if I do self unit is leader, I'm going to get false. But Juju only guarantees leadership leases for 30 seconds, I think. So if I call this function in 30 seconds from now, it might return something else. Which, by the way, for a charm, 30 seconds is a lot of time. So usually you don't have to worry about it. And as the charm runs the observers, most of the data, such as relation data, is buffered and, let's say, cached, and only flushed and synchronized with and submitted to the controller when the charm exits 0. Otherwise, it is discarded. The same holds for secrets, by the way. Yeah, so this might be useful to know. Are there any questions on this? Anything you would like me to expand upon regarding debug hooks and debug code? All right. So before I talk about testing, which is one of my favorite subjects in Charming, I'm going to show you how to add, let's stop and fast forward, how to add integrations for the canonical observability stack to essentially make your charm observable. This not only to advertise my own team, the observability team, but also because being observable is one of the requirements of a production-ready, or as they say nowadays, a mature charm. So I advise you to think about observability in your charm sooner rather than later, and set up your charms in such a way that they can submit logs, telemetry, traces, all of the observability information that makes sense for your workload as soon as possible, right? So not only because it helps you to debug the charm as you're developing it, but also because before it's production ready, you will have to do it anyway, and it's easier to do it earlier rather than later. For those who want to go and just see the code instead of, well, actually, let's do that because where's my cursor? You can check out the Part 3 Observability branch in the Intro to Charming FC repository. And we're going to go now through what I did to get there. We are working on a machine charm. For Kubernetes charms, the story is different. But in machine charms, you have to work with subordinate charm that is called Grafana agent. Okay, maybe I started a bit too close to the to the truth. Let's switch to a microK8s localhost controller where I have a COS Lite deployment. COS Lite stands for Canonical Observability Stack and is a bundle or a bunch of charms related to one another. You can see that there are a lot of relations involved. So it's a fully integrated observability stack composed of 6 different charms. And it runs on Kubernetes. Not only it's good practice for your observability stack to run on a different infrastructure and substrate than the stuff that you're observing, but also these are all Kubernetes native workloads. So that is why we develop COS Lite as a Kubernetes bundle. So suppose that you set up your local Kubernetes controller or EKS instance or whatever Kubernetes compliant cloud you like with COS Lite, and it's as simple as Juju deploy COS Lite channel edge trust. We need you to trust us, and we can do that from scratch. COS Lite demo. Let's deploy COS Lite channel edge and trust. As soon as this bundle is deployed and ready, this is going to be your observability stack, which is, let's say, is ready to start receiving metrics and logs and, well, in the future, traces once we add tempo to it from your workload. And now, what do we need to do in your workloads in order to enable them to send metrics and logs and all to the canonical observability stack? Let's go back to the model. This is COS Lite, yeah. So the first thing you need to do is to download the library for called COS agent, which lives under the Grafana agent charm. So that's, again, as we saw last time, using charm graph fetch lib charms Grafana agent v0 COS agent. Is it underscore or dash? I guess it's underscore. There we go. That is going to obtain for you this library, which is a lot of code. We don't need to go through it, but this is how you use it. As I mentioned earlier, this follows the common pattern in charm libraries of exposing a provider and the require object. And in this case, Grafana agent is a subordinate charm, and our charm, the charm that we want to observe, is the principal charm in that subordinate relation. So it is the provider, because, yeah, it provides the information it needs to the Grafana agent. It provides the metrics, it provides the endpoints, how you can see it. And we need to give it a relation name, which is the endpoint of the subordinate relation that we're going to use to communicate with the Grafana agent. We have to give to it metrics endpoint and a path. In this case, we are deploying nginx. So all that I did was Google nginx metrics endpoint, and it turns out that nginx has a built-in metrics server exposed at this path on port 80, so on localhost port 80. Then we can add some alert rules for Prometheus. Prometheus is the alert rules. This is part of how the API of this COS agent provider library works, but it expects you to pass to it a directory relative to the charm root. So inside src alert rules, there's going to be a directory, and in there you can put rule files. And, well, how to develop alert rules is subject of months and months of courses that I'm not going to replay here. But what I did for nginx, because it's quite a popular piece of software, so smarter people than me have worked out fantastic Prometheus rules for it. You can visit this website, which is Awesome Prometheus Alerts, and perhaps the piece of software that you are charming already has some alert rules in here, or maybe in some other repository. I mean, you can do some searching to find out what kind of rules you need. But I clicked on nginx, and I shamelessly copy-pasted a bunch of these alerts, and I put them in here. So these alerts are going to raise warnings if some critical metrics, such as the rate of HTTP 400 or 4XX errors, exceeds a given rate, such as the 5% of total. With this configured, so we have alert rules and we have an endpoint at which we can expose the metrics, the COS agent provider is going to do the rest for us. So all that you need to do in your charm is instantiate this object, and for the rest, you can basically forget it. That is so far as the charm code is concerned, because you also do still need to add a relation to your charmcraft.yaml or metadata.yaml file. Limit 1, because it's a subordinate relation. I don't even think you can have multiple over the same interface. And the interface name needs to be COS_agent, but this endpoint you can call whatever you like, provided it is the same as what's in it. With this, the charm is ready to pack. And once that is done, we can see how you can do charm upgrades, or, well, refresh. That is not something we discussed yet, but charm upgrades work. Yeah, like there are several situations in which you might want to do a charm refresh instead of just JHack syncing your file there. For example, if your dependency changed, if you've added a file that was not there before, then you need to repack the charm and update, and let's say push the new charm into Juju, which you do like this. Juju refresh, nginx, path, intro to charming, and so on. What this is doing is copying the charm file to the existing unit. So instead of provisioning a new unit, Juju is going to keep the old one, but unpack this new charm in a different folder, and then I think just swap the two folders so that the next event is going to be processed by the new charm. There is a sequence of events that you will see when there is a charm refresh, which is this upgrade charm. Let's reset this. 5 minutes. Otherwise, I'm going to see too many of these update status events. But yeah. So now that we have done the charm refresh, so the nginx charm that we have there is, if everything went well, ready to accept a subordinate relation with Grafana agent. So let's deploy Grafana agent. We deploy it to a unit called Gagent, and we fetch the edge channel. Now, this is a subordinate charm, and we have not talked about it yet. And to be honest, I don't know a great deal about the whys and whats of the design of subordinate charms, because I'm more of a Kubernetes charm person. But one thing is sure, when you deploy a subordinate charm, it does not, like Juju does not provision a machine for it immediately. It does not appear as a unit yet, because it's a subordinate charm. And what it means is that it's going to be deployed in the same machine as another charm that you attach it to. So unlike the nginx or the tester charm, which have their own machine for themselves, the Grafana agent charm, being subordinate, is going to need you to tell to it, attach yourself to one of these existing machines and units. So, and the way you do that is by specifying a relation. Juju relate agent nginx what this is going to do is it's going to create an nginx unit, create a Grafana agent unit and attach it to the nginx charm. We see it here, executing, and this is now the Grafana agent charm doing its thing. We see it goes to maintenance. It's installing the Grafana agent snap. It gets picked up by jhacktail as 2 events, which is interesting. Not sure why. Maybe it's emitting logs that I have not filtered properly in jhacktail. I don't know. A disclaimer. I work mostly with Kubernetes charms, so I have tested JHack a lot less on machine charms and workloads and models. So you might find a bunch of bugs, but please let me know. I'm more than happy to work with them. Okay, so we see that Grafana agent. All right, so someone in the chat asks, will it attach itself to the leader in case units are scaled out across multiple machines? Not only, no. I think a separate Grafana agent unit will be provisioned for each unit of the application it's attached to. So if I scale up nginx, there's going to be an nginx 1 and an agent 1 attached to it. Yeah. All right. Now, we have Grafana agent. It complains that it's blocked, and it is blocked because we have not added relations yet to the COS Lite model.
Let me share my screen just a second in order to show what I have here. You see my screen? Yes. Mm-hmm. All right. So what we need to have right now is in here we have COS Lite running. And here we have another model, an LXD model with the intro charm deployed and Grafana agent, the same way Pietro did. But in this model here, in the COS Lite, we are offering a lot of endpoints, so other charms can connect through cross-model relations, right? And yesterday my wisdom tooth was removed and I speaking like an idiot, so that's why you are not enjoying my charm accent, my posh accent today. Okay, what I'm saying here, we have the LXD model in which we are consuming the offers that the COS Lite bundle is offering, right? Maybe just to understand what the relations are established, Pietro, maybe we can execute this manually. I can paste you the commands.
Yeah, that's okay.
In fact,
sorry, I cannot hear anymore.
No, I'm going to stop my presenting.
Okay, Juju offer, for example, you go key logging, then Prometheus metrics endpoint, and then Prometheus remote, all right, receive.
It's not only remote write, receive remote write. Yes.
Yeah. And then we have
Grafana dashboards.
Grafana dashboard. Now we can do Juju find offers, and we can find indeed a bunch of offers. And now we need to do Juju consume.
Juju consume the name of the controller, :admin /
for example, this thing.
Yes.
Yeah. So this is why I hate to do this manually.
While Pietro is executing this, just to clarify, from the COS Lite bundle, we are offering our endpoints by running Juju offer. From the Grafana agent, from the LXD controller in which Grafana agent is running, we are consuming those offers. And at that point, we are only offering and consuming offers, but the relation is not yet established between Grafana agent and all the charms in COS Lite, right? Is it clear? Great. Now, when the offers and when we have the offers and we are consuming, we just relate both words as a regular relation, right?
Just to a quick way to verify that the data is being received by the observability stack, what I did was switch to the microcrates model, get the IP address of the Grafana charm, of the Grafana unit, obtain the admin password from Grafana, somewhere up there. You can run an action on the charm. We didn't talk about actions, I know, but there wasn't enough time. You need to run an action on the charm to obtain the admin password. Then I was, at that point, ready to go into that IP address, and using that admin password, you can log into the Grafana dashboard. And in the Grafana dashboard, well, there are, first thing, built-in dashboards that we provided. And if you want, there is also a website at grafana.com where you can browse existing dashboards for whatever workload you can think of. For example, there are tons of nginx dashboards that I could pick from, and I could just copy paste that into my demo charm, and that would appear in here, offering me pre-built dashboarding solution for my workload. In our case, we didn't implement a dashboard, so you can verify that there's data coming in by checking, for example, what logs are coming in for the nginx 0 unit. I run this query and I obtain essentially the Juju debug log. With the Juju topology, right? So what you can imagine is once you have 100 of these units and you see an error coming up in one of them, and you see the logs with the error message, the labels that we inject include the Juju model, the application, model UID, and unit name. So this is what we call the Juju topology, and that is essentially a fingerprint of the Juju unit, which is responsible for the error. So you can find from a log, from an error message, exactly what Juju unit is causing that error. Is there anything else you would like to show here, Jose?
No. Just a little comment. When you see all the relations that are established, You can make sure that your application is sending telemetry to COS Lite, metrics, logs, and also dashboards. So this cross-model relation behaves like a regular relation at some point. So shouldn't be complex, right?
So I will give you 5 minutes primer to charm testing, which, yeah, I realize is nothing, but it's so much material to go through. The model, so the way that I like to think about charm execution, and I've mentioned things out of this picture already before, is that of a state transition. So I see each charm execution as a state transition between, between an input state and an output state, caused by an event, right? So there are two things that come in, which is a state and an event. There is the charm itself, which is kind of the context in which this state transition takes place, and then there's an output state. So as input state, you can think, for example, the status, the content of the data bags, the relations that are established, and so on. And what the charm does is essentially conditionally on that state do something. For example, conditionally on what event I am processing, do something, or conditionally on the presence of a relation or the contents of a relation. For example, if the remote end has already sent this piece of data that I'm waiting for, then I publish, for example, a piece of data of my own. So this is state transition model of charm. And the way that there is a testing framework that I developed over the past year or something that is called Scenario. The package name is called Ops Scenario because it's a plugin, essentially a testing plugin for Ops. And the way it works is as follows. You define a context, which is like it takes as input the charm, and maybe you're familiar with the harness, which is a built-in in the Ops framework, and it's kind of similar. So it takes this charm and it acts as a context manager. It takes all of the metadata files that are attached to a charm. It takes the Juju version and it kind of sets up the context for the simulation. That is, in fact, the main entry point for scenario tests. I'm using PyTest fixtures. I hope you're familiar with those. I define the input state, and then I run an event on that state. And then you can make assertions on this output state. So, for example, what I'm doing here is I'm verifying the execution logic, especially when it comes to statuses of the install event. So I'm verifying that if the charm receives an install event while it is in the empty state, so while it is in its initial default state where it has no leadership, no relations, nothing else, then it is going through these statuses and it is ending up in active status. And I wanted to mention this because this is how I do the more interactive debugging and development of charm code, because you can put a breakpoint in your charm code debug these events and end up hitting that breakpoint in PyCharm. You can inspect the contents of your local variables, and you can essentially interact with the operator framework and the Charm API as if you were in a real live charm, right? The promise of Scenario is that it offers a complete mocking backend that you can test your charm code with. So this is the subject of 3 more tutorials. So I just hope I made you interested with this, and you can go and look up the documentation and more. But for example, suppose that I want to test my charm under some more exotic conditions. For example, I am the leader, and I have a relations over demo ingress. I'm re-executing this code. I'm hitting there, and now if I go and ask ingress provider, what relations do you find over demo ingress, it's going to find 1 relation because I have specified it in the state, right? If I remove this line and I rerun this thing, it is not going to find any relation in there. So this is how I write all of my testing code for my charms. And yeah, there are more advanced experimental features on like helping you to obtain a state from an actual charm, so you can reproduce what you're finding on your model in a unit test just on your local machine. But yeah, this is as close as you can get to interactive debugging with something like PyCharm in your charm code. And with that, I'm going to stop the recording.